For more than a century, residential water systems have followed a linear model. Water enters the house from a single pipe. It is used once. Then it disappears into the sewer. This design made sense in an era of abundant resources and centralized infrastructure. But in a future defined by climate uncertainty, energy constraints, and growing cities, a linear system becomes a point of vulnerability. Environmental engineering is now redefining the home as a closed-loop water ecosystem, where water is produced, treated, reused, and stored within the same building, not as an emergency solution, but as a new standard for resilient living. Designing a residential water independence loop begins with understanding demand. Not all water inside a home needs to be drinking quality. Only a small percentage is used for consumption and cooking. The majority supports washing, flushing, cleaning, and irrigation. By separating water use according to quality requirements, engineers can design systems that allocate high-quality water only where it is truly needed. This single step dramatically reduces total demand for potable water. A resilient home does not rely on one source. It combines multiple decentralized inputs: atmospheric water for drinking quality, supply, rainwater for non-potable and seasonal storage, a reduced municipal connection as backup. Each source has a different reliability profile. Together, they create continuity. This is the core principle of loop design. Diversification increases security. Storage transforms intermittent production into continuous availability. But in a closed-loop system, storage is not passive. Smart tanks monitor water levels, water quality, temperature, turn over time. This prevents stagnation, maintains hygiene, and allows the system to automatically select the optimal source. Storage becomes the central decision-making node of the building's water infrastructure. The second half of the loop is reuse. Greywater from showers, bathroom sinks, and laundry contains relatively low contamination and can be treated on-site. Compact biological and membrane systems can process this water for secondary uses, such as toilet flushing, landscape irrigation, cleaning operations. This reduces total freshwater demand and keeps water inside the building's cycle for longer. In a loop system, water is not consumed once. It performs multiple functions. A closed-loop system requires intelligent control. Sensors and automation manage source selection, treatment activation, storage prioritization, leak detection, consumption forecasting. The result is a responsive infrastructure that adapts to weather conditions, occupancy patterns, and energy availability. Water becomes part of the smart home ecosystem, not a hidden utility. Designing independence does not mean compromising safety. Closed-loop systems must comply with health regulations and include backflow prevention, cross-connection control, certified treatment performance, continuous monitoring. These measures ensure that decentralized systems deliver water that is not only available, but safe. This is where environmental engineering bridges innovation and public health. Although installation requires investment, the long-term performance of loop systems changes the economics of housing. Reduced water bills, lower energy for pumping and heating, increased property value, protection against supply interruptions. instead of paying continuously for external resources. The building begins to produce and manage its own. Independence becomes an asset. A residential water independence loop is not a single technology, it is a system. And it transforms the house from a consumer of water into an active part of the urban water cycle.